let's just move on further and talk about the ratios. We already know that what are ratios. So it is actually a comparison in between the two things. Now we are moving on further in the trigonometry chapter, and we are talking about the trigonometric ratios. It is a very important concept in which we will talk about the ratios of the two sides of a right triangle. So let us suppose if I am just starting with the trigonometric ratios, so we will first of all take a particular right angled triangle. So let us suppose this is my right angle triangle. So as you can see over here, in this right angle triangle, angle B is nothing but of 90 degree, and here we have taken this particular angle A. So my whole concentration is actually on this particular angle now, because with respect to this angle we will talk about the sides of this particular triangle. So let us suppose if this is my angle A, so with respect to this angle A, we will say that this side, which is nothing but BC, is called as the side opposite to the angle A. As you can see, with respect to A, this is nothing but the side which is opposite to the angle A. So what is this side? This side is BA, which is nothing but called as the side which is adjacent to the angle A. So always remember, when this angle is in my concentration, or if I'll say I'm taking this particular angle, so with respect to this angle, this side is called as the side opposite to A, this side is called as the side adjacent to the angle A, and this side is definitely called as nothing but the hypotenuse. This side is called as the hypotenuse. So this is the whole notation of the different sides and the angles if I'm just taking the angle A. But let us suppose if I am taking the angle C, rather than taking this angle A, if I'm taking this angle C, then the sides position will get interchanged. What does it mean? Let us suppose if I'm just taking this particular triangle, now you can see over here that I am just taking the angle C. So with respect to the angle C, now the position of the sides will get changed, means this particular side and this particular side, they are called as the side opposite to the angle C, and this side would be called as the side which is adjacent to the angle C, as you can see. And compare from the previous particular right triangle, this side is now the side opposite to the angle C, but before this particular figure, it was the side adjacent to the angle A. So if we are changing the angle, it means that the sides are changing their positions as well, but hypotenuse remains the same. So this is my hypotenuse again. So always remember, with respect to the angle, will always change the position of the sides. So this side is called as the side opposite to the angle C. As you can see, this is the side which is opposite to the angle C, and this side is nothing but called as the side adjacent to the angle C. Now let's just talk about the ratios. So how we can find the ratios? Ratios is actually we can say a comparison or a ratio in between the sides of this particular right triangle. So let us suppose if I'm just taking the first figure again, if I'm just talking about this particular figure in which I am taking the angle A. So what are trigonometric ratios? What are trigonometric ratios? So let's just see. The trigonometric ratios are again the ratios of the side lengths of this particular triangle. So let us suppose if I'm just talking about the trigonometric ratios or the basic trigonometric ratios. So what are those? So trigonometric ratios are, let's just start with the angle A. So if I'm just talking about this particular angle A, so we have the 6 basic trigonometric ratios. And what are those? Let us suppose if I'm just writing it over here, this would be sine of angle A. This is nothing but called as the first trigonometric ratio. Sine of angle A. This is my first trigonometric ratio, which is actually nothing but a ratio of the two sides. So let us suppose if I'll write it over here, so it would be beneficial for me. This side was actually called as the side opposite. It is called as the side opposite to angle A. This was called as the side opposite to the angle A, and this side was actually called as the side adjacent. Side adjacent to the angle A. And this was called as the hypotenuse. So let's just start with the sine of angle of A. So actually sine of angle of A is a ratio of the side opposite to the angle A and the hypotenuse. So sine of angle A is nothing but side opposite to angle A. Let us suppose if I am writing angle A as this, side opposite to angle A divided by hypotenuse. So as you can see, the sine of angle A is the first trigonometric ratio which is actually giving us a ratio in between the two side lengths of this particular right triangle. So as you can see, this is side opposite to the angle A divided by hypotenuse, and we can also write it as nothing but BC divided by AC. This is the very first trigonometric ratio which is called as the sine of angle A. Now let's just talk about the second one. The second one is nothing but cosine of angle A. So cosine of angle A is nothing but is equal to side adjacent to angle A divided by the hypotenuse, which is nothing but is equal to AB divided by AC. So as you can see, cosine of angle A is my second trigonometric ratio which is providing us a ratio of the two sides, that is nothing but AB by AC. Now let's just talk about the third. Which is called as the tangent of angle A. So the tangent of angle A is nothing but side opposite to the angle A divided by side adjacent to the angle A, which is nothing but is equal to BC divided by AB. AB. So these are my three trigonometric ratios. Now let's just move on further and talk about the other trigonometric ratios. So the fourth trigonometric ratio is nothing but cosecant. This is cosecant of angle A. So this type of trigonometric ratio is actually very special because cosecant of angle A is actually the reciprocal of the sine of angle of A. It is actually a reciprocal of sine of angle of A. So as you can see, the sine of angle of A is actually nothing but side opposite to angle A divided by hypotenuse. So this would be nothing but hypotenuse. Divided by the side opposite to angle A. So we can write it as nothing but AC divided by BC. This is my fourth trigonometric ratio. Now let's just move on further and talk about the fifth one, which is called as the secant of angle A. So secant of angle A again is nothing but a reciprocal of cosine of angle of A. As you can see, the cosine of angle of A is nothing but side adjacent to angle A divided by hypotenuse. So this can be written as hypotenuse divided by the side adjacent to angle A, which is nothing but can be written as AC divided by AB. So this is my fifth trigonometric ratio. Now let's just talk about the sixth one. So sixth one is nothing but called as cotangent of angle A. And cotangent of angle A is nothing but again a reciprocal of tangent. It is a reciprocal of tangent of angle A, and tangent of angle A is nothing but side. It is adjacent. So this is adjacent. Side adjacent to angle A divided by side opposite to the angle A. So this can be written as nothing but AB divided by BC. So hence these are the 6 trigonometric ratios which are related with this particular right triangle, which is right angled at B. And since we are concentrating on the angle A, so we are taking these trigonometric ratios with respect to the angle A. As you can see, I have written already over here that we are taking sine of angle A, cosine of angle A, tangent of angle A, cosecant of angle A, secant of angle A, cotangent of angle A, and so goes on. So always remember, these are the basic 6 trigonometric ratios on which we have to work on this whole chapter. So these will definitely help us to solve out many such questions, and these are our basic base of this particular chapter. And now again, these 6 trigonometric ratios are abbreviated as nothing but sine, cos, tan, cosec, sec, and cotangent. What does it mean? We can abbreviate the sine of angle A. We can write sine of angle A. We can write sine of angle A is nothing but sine only sine, as sine of angle A. We can write it as nothing but sine of angle A, or we can also write it as sine of A. And further, this cosine is abbreviated as cos. So we can write cosine as cos. We can write sine, S-I-N-E, as only S-I-N, sine. We can write cosine as cos, and further we can write tangent. We can write tangent as tan. We can write cosecant as cosec. We can write secant as sec, and further we can write cotangent as nothing but cot only. So these are the basic abbreviations that we have to use in this particular chapter. We won't write cosine, and we won't write secant, cotangent, the whole wordings. We won't write it. We always use sine, that is S-I-N. We'll use cos in place of cosine. We will use tan in place of tangent. We will use cosec in place of cosecant. We will use sec in place of secant, and we will use cot in place of cotangent. So always remember, whenever we are just talking about sine of angle A, means we are talking about sine A. Whenever we are talking about cosine of angle A, so we are using cos A. Whenever we are talking about tangent of angle A, we are talking about tan of A. And further, cosecant, cosec A. Further, secant, sec A. Further, cotangent, cot A. So these are the basic abbreviations that we have to use in place of all these sine, cosine, tangent, cosecant, secant, and cotangent. So these are the basic abbreviations that we are going to use in place of all these. And furthermore, here you can see a relationship in between the cosecant and the sine. As you can see over here, cosecant, or we can say cosec and sine, they are reciprocal of each other. As you can see from this particular relationship, they are nothing but the reciprocal of each other. And further we can see secant and cosine, they are again reciprocal of each other. Further, tangent and cotangent, they are the reciprocal of each other. So you can see from this particular relationship that they are reciprocal of each other. Further, there is a relationship of tangent, sine, and cos. What is that? That is, suppose if I'll write it over here, a special note. As you can see over here, if I'm just talking about the cosecant A, so I'm writing the abbreviation cosec A. Cosec of angle A is actually nothing but 1 by sine of angle A. This is nothing but the relationship. And further, second, if I'm talking about the secant of angle A, so this would be nothing but sec of angle of A, can be written as 1 by cos of angle of A. And further we can say that cotangent, that is cot of angle of A, can be written as 1 by tangent of angle of A. And many a times in place of angle of A, we can write only A as well. Means we can also write it as we can also write it as 1 by tan of A, 1 by tan of A, 1 by cos of A. We can also write it as 1 by sine of A. Many a times we also use this particular representation rather than this one. And again, there is a special relationship 4, which is nothing but tangent of A, tangent of A. As I'm saying that in place of angle of A, we can also write only A as well. So tan of A is actually nothing but, as you can see, it is a ratio of BC by AB. It is a ratio of BC by AB. So let us suppose if I'll write it over here that it is BC by AB. Furthermore, I can write this particular relationship as BC by AC divided by AB by AC. So as you can see, I have divided AC in the numerator as well as in the denominator in order to make it into the formation of sine and cos. So as you can see, BC by AC is actually nothing but a ratio of a sine of angle A. Means this representation can be written as sine of A divided by, further, AB by AC. As you can see, AB by AC is nothing but representing cosine of angle A. It means we can write it as nothing but cos of A. So hence tan A is actually provides us a relationship as it is a ratio of sine A by cos A. So hence tan of A is nothing but the sine of A divided by cos of A. So these are the special notes that you always have to remember, that cosec is actually a reciprocal of sine, or we can say sine is a reciprocal of cosec, sec is a reciprocal of cos, cos is a reciprocal of sec, cot is a reciprocal of tan, tan is a reciprocal of cot, and tan of A can be written as sine A by cos A, and further we can also say cot A. Further we can say cot A is nothing but cos A by sine A. So these are all the trigonometric ratios or the relationships, as you can see, we can form from these basic 6 trigonometric ratios. So always remember, these are the 6 trigonometric ratios with the help of which now we will solve the other topics, or we will use them in other topics as well, and will solve the problems that are related with it. Now let's just talk about some of the important remarks that are related with the trigonometric ratios. So the very first remark is the symbol sine A is used as an abbreviation for the sign of angle A. So this is already given by me to you as well, because I also already have told you that the sign of angle A is actually abbreviated as nothing but sine of A. So this is the very first remark which says that the symbol sine A is used as an abbreviation of the sign of the angle A, and furthermore sine A is not a product of sine and A. So as you can see over here, sine A is not a product of sine and A. Sine separated from A definitely has no meaning at all. So always remember, sine A is not a product of sine and A. They if they are individuals, means if you'll take sine and A separately, then they do not have any meaning at all. And similar interpretations can be made for other trigonometric ratios as well, means for the cot, for tan, for cosec, and for sec, and so goes on. So this is the very first remark. Always remember this particular point. Now let's just talk about the second remark. The second remark is the values of the trigonometric ratios of an angle do not vary with the length of the sides of the triangle if the angles remain the same. So if the angle remains the same and the length of the sides may be any, so the trigonometric ratios do not vary at all. So this is another remark which is related with the trigonometric ratios, and definitely trigonometric ratios that we are finding out, they are nothing but for the acute angle in a particular right triangle, and it also is nothing but providing us a relationship in between the angle and the sides, because if we are talking about sine A, it is nothing but is equal to the side opposite to the angle A divided by the hypotenuse. So it is actually providing us a relationship of the angle and the lengths of a particular right triangle when the angle we are taking is nothing but acute. Now let's just talk about the third one. Since the hypotenuse is the longest side, obviously as we have seen, since the hypotenuse is the longest side in a right triangle, the value of sine A or cos A always less than 1 or in particular equal to 1. So this is a very special important remark, that since the hypotenuse is the longest side, so sine A cos A always remains less than 1 or it can be particularly equal to 1, but it always remain less than 1. Now we also can able to remember all the trigonometric ratios through a particular result. So let us suppose if I am just talking about this particular right triangle. If I am taking this particular right triangle, and if I am taking this particular angle A, this is my B, this is my C. As since we call this particular side as nothing but the perpendicular, we all know about this. We call this as perpendicular. We call this as nothing but the base. We call this as nothing but the hypotenuse. This is called as nothing but the hypotenuse. So since if we are talking about the trigonometric ratios, so we know that sine of A is nothing but actually is equal to it is equal to the side opposite to the angle A divided by the hypotenuse. So now we can write it as nothing but perpendicular by hypotenuse. This can be written as perpendicular by hypotenuse. So rather than learning that sine A is nothing but is equal to the side opposite to the angle A divided by the hypotenuse, you can also learn it in this way, that sine of A is nothing but perpendicular by hypotenuse, where P is the perpendicular, H is the hypotenuse. Further, if I am talking about cos of A is actually nothing but a relationship of base and hypotenuse. Base actually representing the side adjacent to the angle A divided by the hypotenuse. So you can also learn this in this manner. Furthermore, if I am talking about tangent, means tan of angle of A. So this is nothing but perpendicular by base. This is perpendicular by base, means the side which is opposite to the angle A divided by the side adjacent to the angle A. Furthermore, if I am just talking about the cosec of A is actually nothing but a reciprocal of 1 by sine of A, and we can learn it as nothing but H by P. So this is nothing but obviously a reciprocal of this one. And further, if I am talking about sec of A, so sec of A is nothing but 1 by cos of A, and we can write 1 by cos of A as nothing but H by B. And furthermore, we can learn this tangent as nothing but cot of A. Cot of A is nothing but 1 by tan of A, and we can learn this as nothing but B by P. So this is nothing but a way through which you can learn the trigonometric ratio in an easier manner, rather than learning the side opposite to the angle A and side adjacent to the angle A. You can learn all these trigonometric ratios in this manner, that this is nothing but the ratio P by H, this is B by H, this is P by B, and so goes on. So the basic 3 trigonometric ratios that we have to learn is nothing but these 3. As you can see, we have P by H, we have B by H, we have P by B. So these 3 ratios are really important, because if these 3 are nothing but known by you, means if you know about these 3, then you can form the other 3 all by yourself. So always remember, P by H always represent sine of A. This is nothing but sine of A. This is nothing but cos of A, and this is nothing but tan of A. And their reciprocals would be nothing but this is nothing but cosec of A, this is nothing but sec of A, and this is nothing but cot of A. So this is nothing but all about the important remarks that are related with the trigonometric ratios.